Classifying triangles. Our objectives are to classify triangles by their angle measures and side lengths, as well as use triangle classification to find angle measures and side lengths. Who uses this? Manufacturers use properties of triangles to calculate the amount of material needed to make triangular objects. Let's look at some triangle classification. This is by angle measures. So an acute triangle has 3 acute angles. An equiangular triangle has 3 congruent acute angles. A right triangle has 1 right angle, and an obtuse triangle has only 1 obtuse angle. The reason being because you cannot have a triangle with more than 1 obtuse angle. Let's look at classifying triangles by angle measures. Alright, so let's look at triangle EHG. Triangle EHG. That is this big triangle here. Well, you've got a 30-degree angle, a 60-degree angle, and a 90-degree angle. So, because it's got a right angle, you know it is a right triangle. Now we have triangle EFH. EFH. We have 30 degrees and 30 degrees. And a triangle is 180 degrees. So we know that this angle must be obtuse. Let's look at classifying by side length. An equilateral triangle has 3 congruent sides. An isosceles triangle has at least 2 congruent sides. You can think of it this way. An isosceles triangle can also be an equilateral triangle. An equilateral triangle is just a very special isosceles triangle. A scalene triangle has no congruent sides. So let's practice. Classify each triangle by its side lengths. We have triangle ABC. Well, they labeled BC as being 15 as well, so therefore it is equilateral. Now we're looking at triangle ABD. That would be the large triangle here. So we have a side that's 15, one that's 18, and one that is 20. None of the side lengths are the same, so therefore it is a scalene triangle. Let's use triangle classifications to find side lengths. Okay, well, we have that an isosceles triangle, so we know 2 of the sides are congruent. So the 2 sides that are congruent are the 2 sides that we're going to set equal to each other, because we're going to need to figure out what x is to be able to substitute it in and know what the length of JLR, JK is, and LK is. So we have x plus 3.2 equals 4x minus 1.3. So we can subtract x from both sides of the equation, and we can add 1.3 to both sides of the equation. Well, let's make that line a little bit straighter. Not quite sure what's going on here. Here we go. Let's try this again. There we go. Hopefully that will work. Alright, so we have 3x. We're subtracting 1.3 from, or adding 1.3 to both sides. So we've got ourselves 4.5 equals 3x. And now we can divide both sides by 3. And when we do so, we end up with 1.5 is x. But we're not done yet. We want to substitute that into each of our values here. So we have 5 times 1.5 minus 0.2. And 5 times 1.5 minus 0.2 will give us 7.3. And then we can substitute 1.5 into here. So we've got 1.5 plus 3.2 which would give us 4.7. And this side should be 4.7 as well, but when we double check and we put 1.5 in, we have 4 times 1.5 minus 1.3, and that is in fact 4.7 as well. Let's look at a music application. A manufacturer produces musical triangles by bending pieces of steel into the shape of an equilateral triangle. The triangles are available in side lengths of 4 inches, 7 inches, and 10 inches. How many 4-inch triangles can the manufacturer produce from a 100-inch piece of steel? Well, we're looking at equilateral triangles, so each of the 3 sides will be 4. So for one triangle, you need to figure out how many inches it would take for one. So 3 sides times your 4 inches means that each triangle needs 12 inches of steel. So then you can take your 100, because that's what they're giving you, and divide it by your 12 inches. And you end up with 8 1/3 triangles. However, can you have 1/3 of a triangle? No, not and have a sound that you're looking for. So therefore, it can make 8. And that concludes our video on classifying triangles.